Okay guys, welcome back to my Smarter R YouTube tutorial for how we can use R, employ R to do a lot of statistical analysis for climate change and all other things that you want to do. So, but in this case, we will learn how to use R and then calculate ANOVA test and what we call this Tukey's HSD and eta square actually. So we want to do ANOVA test. We want to do pairwise comparison of monthly rainfall. So this is one of the example, but you can do all analysis to compare pairwise comparison with other study like maybe water quality with water quality parameter and so on to understand what is the relationship between all of these parameter. But in this case, I will just use rainfall data. We have 12-month rainfall data to do a pairwise comparison by using uh, ANOVA test and Tukey's HSD. So let me show you entire screen. Okay. So this is the R code that I have prepared for ANOVA test and Tukey's HSD and eta square for monthly rainfall. But the data is up to you. But we want to use monthly rainfall. So you use the library reshape tool and then go to my dataset. Let's see, my dataset is here in this folder. So this is our dataset. This is the data. The dataset is monthly rainfall from 1981 to 2022. So I want to make a read this dataset, read this working directory, read this dataset, and then we shape the data from wide to long format. So how does it look? Let's see. Rainfall long. So it will look like this. Each January and then February and then March, April, May, June, July, August, September, October, November, December, and then mean. So it's look like this. But actually I don't need mean, but it's okay. I can compare means also with all other months. So we arrange that data like this just now. If you already have the data that looks like this, then you can use this data. But usually the data that we have is usually like January, February, March, April, May. It's not January for all year, February for all year. So we need to rearrange again the data to looks like this. So this is the rainfall long. We melt the data just now. Year, variable name, months, and the value rainfall. Okay, now convert months column to factor with correct level. Okay, make it correct, and then we can see how does it look like. The data will look like this. See, so this is the data. It's look like this. Now view the first row of the reshape data. So the reshape data is look like this. We can this. So I like to use view function actually. So we can see the whole data like this. Use the view function. So we can see our data, how it looks like. And then we perform one-way ANOVA test. So we want to perform ANOVA test. We use the function AOV. And then we compare the rainfall with the months and data with rainfall long. So our data is rainfall long. So ANOVA result. So actually we already have our result for ANOVA test actually. Let's see here. ANOVA test. Oh, it cannot be print, but it's okay. Maybe I can do print ANOVA result. Yeah, the result is there. So we have month square, month residual degree of freedom, residual standard error, estimated effect maybe unbalanced 42. So this is all the some of the result generally, but after that we do the Tukey HSD test result, and then we just print. This actually we can just we can up here perform Tukey HSD test for pairwise comparison. We use Tukey HSD. Okay, now we get our result, and then now we print the summary of the result. So we can see the summary, the difference, sum, square mean, square, f value, and so on. and then we print the Tukey HSD test result. This is the result that we have. This is the pairwise comparison. This is the pairwise comparison between, you see here, February to January, March to January. What is the difference? The pairwise comparison result is here. So now we plot. Rather than we look at the print, we plot it. We plot the key result. Now we get the result. It's very nice result. 95% family-wise confident level. So what is the difference between March and January is about negative year to negative year, and this is the zero. Some months is positive, some month is negative when we compare it, and there is difference in mean level of each month. So we can use this result and present it in our paper. If you want to compare, make a pairwise comparison. And then we can calculate ETA square. ETA square value is also very important. You can calculate it manually like this. Extract sum of square from ANOVA result first. Summary ANOVA result, sum square, and then total also we get from sum square, total ANOVA result. So after that we calculate ETA square. So we can print ETA square 0.3665. So what does it mean here? When we put in our result in our study characteristic of rainfall in our study area. So because this pairwise comparison is actually not relevant for my study area for monthly rainfall, but it can be used to understand between the rainfall or something like that. It's very specific understanding, but unnecessary for my study area. But if you do a parameter comparison between water quality parameter or something like that, then it can be useful. But what I'm interested more is in this ETA square. After I get this ETA square, I put the result here. The calculated ETA square value of approximately 0.3665 indicate a moderate effect size in the ANOVA performed on the rainfall data. So what does this mean? This means that the month of year significantly influence the variability of rainfall patterns observed in the data set, with approximately 36.65% of the total variance in rainfall attributed to difference between months. So we understand that there is we want to understand the variability of rainfall, right? We have, like here, you see our study area rainfall variability is very high, but how much is the variability actually persisted in this between all of these months? So we can see here the influence variability is in the data set is actually 36.65% of the total variance in rainfall attributed to difference between months. So this underscore the importance of considering seasonal variation in rainfall study, as different months may feature distinct meteorological condition impacting rainfall level. So the difference between months can be 36%, something like that. So quite significant in our study area. So this is how you can do ANOVA test and Tukey test for Tukey HSD test for pairwise comparison for monthly rainfall. So I hope this information, this tutorial will be helpful for you. You can just watch this video, try to copy this code. If you want this code, you can email me for if there is any if only for research collaboration. Other than that, you can watch this video, and you can watch this video and share it with your friend and do all of this calculation for ANOVA test and Tukey HSD test. Thank you for watching.